Dear children, today we shall discuss the topic boxes and sketches. You see, this is a box. What is shape of it? Cuboid. This is an example of a cuboid, because here you see all faces are rectangular faces. It is also a three-dimensional object. Why it is three-dimensional object? Here you see, this is the length, this is the breadth, this is the height. Three things are there. So we say this is three-dimensional object or 3D object. Suppose I am cutting at these edges, for it, at heights I am cutting it. What am I getting? Let us see. I am getting a shape like this. You see, I am getting a shape like this. So now, earlier it was 3D shape. It was of 3D shape. Now it is converted into 2D shape. You see, here same 6 faces, 1, 2, 3, 4, 5, 6 faces are there. So now I am representing the 3D shape in 2D shape. So you see here, this is called net of a box. After removing the extra flaps, the cutout look like this. This is called net of the box. This is also called perspective drawing. What is perspective drawing? Now the art of representing 3D. First it was 3D. 3D object on 2D surface so as to give the right impression of their dimension is called perspective drawing. Okay. Now we have to fold this shape. Whether I can fold it into a box or not, let us find out. I have to fold along the dots. I am folding it along the dots, you see. Yes, I am folding into it into a cuboid. I am getting a box here. You can see I am getting a box here. So this shape can be folded into a box. Now I am taking another shape. Now you see dotted lines here. I have to fold along those dotted lines. I am folding it. You see carefully. You see, here some extra part is there. It is not covering this part. This part is not covering exactly here. So some extra part is coming out. So from this shape, I cannot make it into a box. Again I am showing it. Just you see, this extra part is coming out. Okay. So I cannot fold this shape into a box. Now you see the shape. Will is this shape fold into a cube? Let me find out. I have to fold this shape along the lines, these lines, whether it is forming a cube or not. What is a cube? In a cube all faces are square faces. Edge of each side is equal. You see it? I am folding it. Yes. I am folding it into a cube. This shape can be folded into a cube. Then I have to see another shape. We have to see whether this shape can be folded into a cube or not. Here you see how many faces? 1, 2, 3, 4, 5, 6 faces. I am folding it along these lines. Here you see 1, this surface, this face is extra. Yes, it is covering here. So, I can also fold this shape into a cube. So, both these figures can be folded into a cubes. Now, see this shape is different from the slide. I am folding it along the dotted lines. Whether it can be folded into a cube or not, let me find out. Let us see. I am folding this shape along the lines. You see here, one extra part, here it is remaining open. So, this shape cannot be folded into a cube. Though there are 6 faces, when I am folding along the dotted lines, this cannot be folded. I am not folding it into a cube. Now, see, this is net on open box. Earlier we discussed net of a cuboid. Now, this is net of a open box. Let me fold it. Whether I am getting an open box or not, let us find out. You see, here I am getting an open box. It is also cube shape. Cube, here also I am getting a cube, just it is open. It is open box. How many faces are here? You see 1, 2, 3, 4, 5 faces. But in case of your cuboid that is closed, there are 6 faces. In case of open box, there are 5 faces. Now, I am taking another shape. Here also you can find 5 faces. Whether I am able to fold it into a open box, let us see whether it is happening or not. You see there are 5 faces, 1, 2, 3, 4, 5. I am folding it. See, so I cannot fold it into an open box. Though there are 5 faces, if I am folding it, I am not getting an open box. So, this is not happening here. Now, we have to match the shapes at the bottom which will fold into items shown above of it. You see below that one square is there, around it 4 triangles are there. We have to fold it. So, what type of object will I get? You see here this one. If I fold it, what type of object will I get? You see in the upper here, this one, I will get this one. This, what is this? This is a square pyramid. You can make it, you can draw this kind of figure in your notebook or on a piece of paper. You fold it, you will get the square pyramid. Similarly, here you see this shape. If I fold it, what will I get? You see here, this is pencil type object. If I fold this one, I will get this one. You can also try it out. Then similarly, here you see square. If I fold it, what will I get? Obviously, I will get a cylinder. Here you see, I am folding a rectangular piece of paper. I am folding it, a rectangular piece of paper. What I am getting? Here you see, I am getting a cylinder. So, this one will be matched with this one. Though it is a square, in both cases, square cases and also rectangle cases, if I fold it, it will be folded into a cylinder. So, this one will be matched with this one. Similarly, here you see this figure. It is like this. If I fold it, what will I get? Let me find out. you see I am getting a cone here. Again I am doing it, you see this is a circle, I have cut some part of it, then I am folding it, I am getting a cone. So, when the last shape is folded, I am getting a cone. So, now you can match the items easily. Now, see floor map of a house. In the slide you can see floor map of a house. When you construct your house, when your father constructs house, he consults an architect for a layout plan. This is like that. This is the floor map of a house. You see here there are windows, doors and layout plan of the house. So, which is the front side of the house? You see here door here is door. So, obviously this is the front side of the house. How many windows are there on the front side? If this is the front side, see there are 2 windows here. See the movement of mouse, here there are 2 windows. Okay. From the floor map we can't make out what a house really looks like or how high the windows are. So, we look for a special way of drawing the house which is deep. We say it as deep drawing to show the length, width and height. A 3-dimensional perspective drawing also called deep drawing. You see first one is the layout map or floor map. Below it there are 4 deep drawings A, B, C, D. Then we have to now find out which one is the deep drawing of the house. You see here in A there is door in front of 2 windows, then in the side there is 1 window at the extreme corner, but at the you see the layout map or floor map of the house, I am see the movement of mouse, this arrow. In the back side there is some space, window is there but there is some space, but in figure A you see you cannot find space in back side of the house. So, this A does not represent the correct deep drawing of this floor map. Then we have to check for B. Here you see door is there, 2 windows are there, but one extra window here which you can't find in the layout map or floor map. So, B can't be deep drawing of this floor map. Let us check for C. Now, you see movement of mouse. Now, one door is there, 2 windows are there. On the extreme one in this side at extreme end one window is there. Here also some space. Exactly this is representing the correct deep drawing of this floor map. Now, just we have to cross check for D. Now, you see here this is the movement of arrow, this is door, 2 windows, here also window, but here you see in the layout map or in floor map window is at the extreme end of the one of the sides of the house. So, but here windows in the middle part. So, this D is not representing the deep drawing of this floor map. Now, look at the floor map of a house, make doors and windows on the deep drawing of the house. Now, you see in the front side it is the door, at one corner you can draw the door there. Similarly, window in the right part 2 windows are there. Here you can see movement of mouse. Here is one window, you can draw here a window, another window here. Here also you can draw the window, but you can't draw this window because this is you cannot see this portion of the house. So, you cannot show this window here. So, in deep drawing every windows can't be shown. Now, see Are there any windows which you couldn't show on the deep drawing? Yes, just we discussed in this part we can show the window. Other windows we could show it, a door is there, but we can't show this window. Similarly, let me get back to this picture. You see again floor map. Here this window also I am not able to show this window in this deep drawing. Now, which are deep drawings of a cube? You see A, can it be? No. B, no. C, no. D, yes. It can be deep drawing of a cube. Similarly, E, yes. F also, no. F will not be deep drawing of a cube, just it is one face of the cube. You test for G, it is a cuboid, it is not a cube. Now, can you add some more lines to make drawing into deep drawing of a cube? You see the figure F, we have to make it into a deep drawing. Let me draw it. How am I drawing it? And I am getting a cube from one face. I am taking 10 centimeter here also. I am joining it just. This is the square. So, you see the figure F, only one face is there. I have to make another face, I have to draw other faces, or I have to draw the lines to make it a cube. I am drawing the edges of the cube. Now, there are two squares. Just I have to add these vertices. I have to join these vertices. So, I am getting a cube here. Now, see, this is bridge using matchboxes. Children, you like to make these kind of designs from matchboxes. Now, you see, if you look at the bridge from the top, where you have to see it from the top. So, how will it look? Here there are two pictures are given. We have to choose the right drawing below. A, one kind of picture, B, another kind. Now, again I am going back. You see the bridge, one is looking it at the top. If you look at the bridge from the top, how will you look? You see in both these cases, the B part, the picture B, it will, you will see that bridge like this. Only you will see the flat surface. Again you see upper matchboxes, the flat surface. Here you see the B will the correct answer for the question. Now, you see this design. You see the movement of my mouse arrow. Here, how many cubes are needed to make this interesting model? Here is a model. It is made up of cubes. We have to find out how many cubes. Now, you see here, how many cubes are there? 1, 2, 3, 4, 5. In this side, you see, in the uppermost layer, in the right side 1, 2, 3, 4, 5. So, here there are 5 cubes. Below also from the top to bottom there are also 5. So, how many cubes are there in this side? So, definitely obviously there are 5 into 5, 25 cubes. I have written here 5 into 5. Similarly, here you see there are 4 cubes. Here also in the heap there are also 4 cubes. So, in this there are 4 into 4, 16. You see here 4 into 4, 16 cubes. Similarly, in this case here you see 3, here also 3. So, 3 into 3, 9 cubes. Now, here also similarly 2 into 2, 4 cubes, here 1 cube. Now, just I have taken or I have counted these cubes, but I have not counted these cubes. So, I have to now count these cubes. You see here 1, 2, 3, 4. This one I have taken earlier for this line. Here only 4. You see here 4 cubes. You see from the top to bottom 1, 2, 3, 4, 5. So, how many cubes are there in this setup? Now, 4 into 5. Here I have written 4 into 5. Then again you see here this cube I have already taken earlier. So, I have to count this. How many cubes in this setup? Now, here you see 3 into 4. You see 3 into 4. 12 cubes are there. Similarly, here earlier I have taken it, only I have to count these cubes. So, 2 into 3, 2 into 3. Again, here it is 1 into this one, 1 into 1, 2, 1 into 2, 1 into 2. This one already I have taken here. So, total there will be 95 cubes in this model. Now, there is another question. Here are some drawings of the model. Mark the correct top view drawing with T and correct side view drawing S. Again you see movement of mouse here, this A. If I see it at the top, only I will see a square. So, exactly this A represent the picture which one will see this design or this model when he see the things from the top. He will see only this kind of picture, that is a square, and among these there are many small squares, or he will see a grid. Now, you see B. If I look here from this side view, if I stand here and look at this side, I will see this kind of structure. So, this is side view of this design. So, this one does not represent its look when one looks from the top. Similarly, this one not, only this one from the top view, and this is the side view of this design. Now, we will summarize the things that we learned today. First, we learned the net of a box. What is net of a box? Then perspective drawing. Then which nets can be folded into boxes? We took example of different nets. Then we tested whether they are folding into boxes or not. Similarly, we learned which shapes can be folded into cubes or not. Then we discussed about net of open boxes. Then we learned what is the floor map. Then also we discussed what is the deep drawing. Then we discussed how does the look of the things change when we see them in different positions. Thank you, children.